Okay, Algebra 2, we are starting our review packet today, and there are 40 questions on this review packet, okay? This review packet you get to use on your test. It'll be like kind of the same 40 questions on the test, but mixed up and different numbers, so it won't be exactly the same questions, but it'll be pretty darn close. So anything that I write on this review packet, make sure you write that down, and also make sure that you are understanding as we go through these problems. If there is something that you do not understand, it would be a really good idea. I know that you can't ask me these questions as you have them in class because I'm not here, but maybe put like a star by them, like, hey, I need to put a star by number 2 because I need Mrs. Comer to explain that to me again because I don't understand where she did this step on it. Okay, that's a really, really good idea to do, okay? Because I promise you, I do have a handful of people that still fail this final even though they get to use this whole review packet on their final, okay? It will not solve the problems for you, okay? So make sure that you are starring or whatever, or ask a friend, how did this happen? What did she write? And maybe I'm wrong, like maybe I made a mistake. So make sure that you are understanding as we go through some of these, okay? All right, I'm gonna try to get through probably, I don't know, I think I'm going to stop before we get to number 13 because 13 is a graphing one and that's just easier to do in person. So, yeah, let's just do 1 through 12 anyway, okay? All right, 1, 2, 3, and 4, they give you the same problem. Like, you're given f of x as this equation, g of x as this guy. This guy, by the way, is a quadratic function. He looks like a parabola. Okay, we don't really care what he looks like, but I'm just, like, just so that you're familiar with this stuff, okay? This is a linear function. He looks like a line, okay? And what they're wanting us to do is they're wanting us to take those two equations and they say f minus g of x, right? Well, this is the same thing as f of x minus g of x. You're just taking this function and subtracting this one, right? It doesn't matter that it's written f minus g of x, because that means the same thing here. Okay, so we're just subtracting those two functions. That's what that means, all right? So I am taking this guy, 2x squared minus 4x minus 6, and I am subtracting this guy. Now, I'm going to be really careful when I subtract because I'm going to put him in parentheses, because when you're subtracting, you need to distribute the negative through. Not for this first piece. That first piece is like before the negative. We don't care about that. But this should end up being minus 2x plus 2, because minus negative 2, right? 2x squared minus 4x minus 6. And now I'm just going to combine like terms and call it good, right? 2x squared, he's going to come first. All right, I can combine the negative 4x minus 2x, that's minus 6x. And then minus 6 plus 2 is minus 4. And that is what f minus g is, okay? That function. All right, now this next one is fg. That means f times g. So that's just f of x times g of x is what that means. Okay, times. I mean, I'm like taking this guy times this guy. All right, 2x squared plus 4x minus 6. That guy times 2x minus 2. Those two times each other, right? Okay, now how do I times? I'm going to like FOIL, except it's a little bit longer than FOIL because I've got like extra pieces in there, but it's fine. 2x squared times 2x and 2x squared times negative 2. So 4x cubed is what this first little bubble is, okay? 2x squared minus or times negative 2 is negative 4x squared, okay? Then I'm going to switch to my next one. 4x times 2x is plus 8x squared. 4x times negative 2 is minus 8x. Okay, and then my last little bit is going to be negative 6 times 2x is negative 12x, and negative 6 times negative 2 is plus 12. Okay, and now I'm going to combine like terms. So this guy's going to go first. He has nobody that we need to add to him. But then I've got negative 4x squared plus 8x squared is plus 4x squared. Minus, this becomes 20x, and then plus 12. And that is multiplied. So you are just foiling and combining like terms. That is all for that one. Okay? All right. This next one. G, and then this open circle. This means G composed of f of x. Okay? Sometimes you will see it as G parentheses f of x. And notice that like the g doesn't have an x on it because the x is the f of x. It's like f of x is going in to g, right? Okay, so f of x is going into g. F of x is going into g. Where that x was right here is now not going to be there anymore. It's going to be all that stuff in its place, right? So instead of 2x minus 2, right? This x is not there anymore. And now it is all that junk. 2x squared, I'm going to write it in a different color even. 2x squared plus 4x minus 6, okay? All right, it's just replacing this little spot, okay? And now I'm just going to simplify as much as I can. And this guy, I can distribute the 2 through. So 2 times 2x squared is 4x squared plus 8x minus 12. And then I've got this minus 2 afterward that I'm just going to let him chill. And the only other thing I need to do is combine these two guys. So 4x squared plus 8x minus 14 is what he is. Okay, and that was g composed of f of x. So we're taking the f of x and we're sticking it inside of the g. Okay? All right, now this next one, last one of this type of problem, right? Number 4. This one is saying not f composed of g of x, right? But they want us to stick a number in there, right? So what you could do is you could take g of x, that whole thing, and plug it into f of x. Like I could take this guy and plug it in here for all of, I would actually have to plug it in 2 places. That would be really gross, okay? But what I'm going to do instead is because I have a number to plug in, okay, I'm going to take this 2 and I'm going to work inside out. I'm going to take the 2 and I'm going to plug it into g of x. And that's going to give me a number, right? Whatever number that is. And I'm going to take that number and plug it into f of x, okay? This is like, composition is like applying the sale and then applying the coupon, right? Like I have something on sale for 50% off and then I have a coupon for another 50% off, right? Well, that doesn't make it 100% off. I take 50% off of the first amount, which let's say is $100, right? 50% off of $100 is now $50. But then I have 50% off of $50 is $25, right? It's applying the sale and applying the coupon. So I took my $100 and I plugged it into the first function. Then I took that number and I plugged it into the second function, okay? So 2 is going into G first. I'm plugging 2 in right there. 2 times 2 minus 2, that's a lot of 2's. That is going to be 2. Well, hey, that was really coincidental. That's not very good. Okay, coincidentally, that's 2 also. So now I'm going to take 2 and I'm going to plug it into F. Okay, so 2 times 2 squared, that's still a lot of 2's. But sorry for all the 2's. Okay, we're plugging in 2, and hopefully we don't get 2. All right, okay, here's what you need to do. I've seen people do this before. Make sure that when you're doing this part, you square the 2 first. You don't take 2 times 2 and then square that. No, 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 no. Okay? Parentheses, exponents. Exponents come before multiplication. So I'm going to take 2 and square it, which is 4. And 4 times 2 is 8. Plus, 4 times 2 is another 8. And then minus the 6. 8 plus 8 is 16. Minus 6 is 10. So 10 is the final answer. Not 2. 2 just got me to the final answer. But that's 10 is the final answer. Okay? All right, next thing, find the inverse. Okay, there are 4 steps to finding the inverse. 1, 2, 3, 4. Okay, step number 1, f of x, he gets switched to become y. Oh, by the way, an inverse is a function that undoes what the other function does. So I'm trying to find the function that undoes this thing, right? Like what function would undo 1/2 x plus 3, okay? So f of x becomes y. So here is now y, okay? And then the y and the x are going to switch places with one another, okay? So this is now x, and I have 1/2 y plus 3, okay? Those two switch places. All right, the third step is the longest one. I'm going to do him in a different color. Solve for y. Now I want to get this y by itself, okay? So I'm going to solve for y. And to get y by itself over here, I'm going to have to get rid of this 3 and get rid of the 1/2, okay? So the thing that I'm going to do first is I'm going to subtract the 3 over. So this is now x minus 3 equals 1/2 y, okay? And the last thing that I'm going to do is to get rid of that 1/2, I'm going to divide by 1/2. But instead of dividing by 1/2, I'm going to instead multiply by 2, because that's the same thing as dividing by 1/2, okay? Multiplying by 2 is going to do that, and so y equals 2x minus 6 is what this thing will be, okay, if I distribute the 2 through. Okay, that is my third step, and then my last step is that the y gets renamed back, and it becomes f inverse of x. Okay, so now instead of calling it f of x like we did up here, he is now f inverse of x, and I have 2x minus 6, okay? Now, if that bothers you, you can flip these two around also and say f inverse of x equals 2x minus 6, whatever. But anyway, there you go. Okay? All right, next, 6. We want to take the square root, and we have 3 pieces. We've got the square root of this guy, square root of this guy, square root of this guy. So here's the deal. I want to take the square root of each piece, and I'm just going to do each piece individually. Square root, square root, square root. Okay, now the square root of 121. That comes out nice. The square root of 121 is 11, so he pops out just perfect. The square root of x squared, x to the 4th, when you're doing this, you're just dividing by 2, right? The square root is just dividing by 2. So x to the 4th becomes x squared. We've just divided by 2, okay? Now the last one is a problem because I cannot just divide 11 by 2. It doesn't work, right? And so what I'm going to do is I'm going to put 10 of them over here and leave one of them off. So together that would make 11, right? I'm just going to hang one of those off. And then I look at, okay, the square root of y to the 10th power is y to the 5th. And the square root of y is just the square root of y, okay? Another way of looking at this, if I were to take 11 and divide by 2, I would get 5 and a half, right? So 5 of them are going to come out on the outside. But the other one is going to stay inside, right? Because he's only a half. He can only, half come out, right? So like that doesn't work. Then all I have to do is put it all back together. So I've got these 3 pieces here, and I'm going to start with the outside stuff. So 11's on the outside. Then I've got x squared on the outside. I've got y to the 5th on the outside. And then I've got a square root of y on the inside. So that is simplified. It actually looks uglier than what I had to begin with, but this one right here is considered more proper than what he was originally. Whatever. All right, next, 7. Graph and state the domain and range. Ugh, this is another graphing one. Yikes. Okay, maybe we should... Oh, these next 2 are graphing. Okay, now, let me just show you. I'm going to zoom out a little bit. There's a difference between this guy and this guy. They both look similar, but one of them is a square root, and the other one is a cubic root. Okay, square root, cubic root. Okay, so a square root, here's what a square root looks like. He starts in the center, and he goes like this. That's what he looks like. Okay, a cubic root, this is what the parent function of a cubic root looks like. He starts here, and he goes this way, but he also goes this way instead as well, right? Because you can have negative numbers inside of your cubic root, but you can't have a negative inside of a square root, okay? So that's why he just starts at 0, 0 and goes to the right, okay? All right, now we've got to figure out, here in a little bit, let's see, right here, on number 12, we're going to write all of the rules for this, okay? But you should hopefully know some of these rules, like this +3, like how does that move this square root? Like what does the +3 do? That moves him 3 to the, I'm just gonna say left 3. How about that? Left 3. The plus, you think plus means right, minus means left, but it's the opposite when it's underneath of here. This guy right here moves him down 1. Down 1. Okay, so I'm going to take this graph and I'm going to move him to the left 3 and down 1. Oof, I don't know if you can see this very well. You might need to make these little lines darker. Left 3, down 1. Left 3, down 1. Okay, left 3, down 1 right here. And then he's going to do one of those. Okay, so just get your rough sketch. This guy right here is at -3, -1. That's where that little thing starts. Okay, and then they want domain and they want range. Okay, now domain and range. Domain is x's, and x's are left and right, right? So this guy will go to the right forever, but he will not go to the left forever. Like he doesn't go any past here, right? And so the furthest to the left he goes is this point right here, which is at -3. So my x's are all greater than or equal to -3, right? Okay, then for range, those are my values of y. So he is going up forever. Like as he goes out, he will continue to go up, right? But he's not going down, and he's not going any lower than that point, right? And that lowest point is -1. So the y's are all going to be greater than or equal to -1, and that's going to be your domain and range. So graph, state, domain, and range. There he is. That is for a square root function, okay? Now, a little bit different for a cubic root function. First things first, this -4 is moving him to the right 4, okay, because minus means right. +2 is moving him up 2, okay? And then we've got one more little thing here. This is moving him or flipping him over the x. So it's like flipping him like this direction now instead, right? Okay, so let's do all of those things. I'm gonna like zoom out a little ways, okay? So instead of being, oh, you can't see these lines very well. Make these lines darker if you need to. Okay, so instead of starting at 0, 0, I'm gonna go to the right 4 and up 2, so right there, okay? And instead of him going this way, right, he's just going to go the other way. So something like this. Something like that, okay? And then these are my favorite, domain and range. Domain is the x's, left and right. Hey, since he's a cubic root function, he's going to go to the left forever and to the right forever, so he's all reals. Range is the y values, going up and down, and since he goes up and down forever, he's going to be all reals as well. So that is always true for a cubic root function, right? Cubic root. Square root is icky. Cubic root, nice. Okay, this dot right here is something called a point of inflection. I call it a POI. Point of inflection is at 4, 2. Okay, so there is that. All right. Let's keep on going. Number 9, we want to solve this thing. Okay, so we're solving both of these, 9 and 10, and the first one is a square root function. So the very, very first thing that I need to do is I need to get this square root by itself. Okay, so I've got this 3 interfering and I've got the negative interfering, and we've got to decide which one is going to get booted to the other side first. Okay, order of operations says subtract the 3. Okay, so I've got negative square root x minus 11 equals, this is going to go away. 6 minus 3 is 3. Perfect. Now I'm going to divide by a -1 to get that to go away. And I've got the square root of x minus 11 equals, and this guy is going to be -3. Okay? Then I'm going to square both sides, right? And when I square both sides, if I square -3, that should end up being +9. So I've got x minus 11 equals +9. And then I'm going to add my 11 over, and that makes 20. Okay? All right, if any of these are going too fast, go ahead and pause if you need to. But there is that. 20 is the answer. All right? Number 10. Okay, I want to get the cubic root by itself first. So I'm going to add the 6 over. So I've got 3, and then I've got the cubic root of 3x minus 1. And if you don't write out all your work, you know, like at least write out a few steps, but yeah, you don't have to be near as thorough as I am. I'm going to divide this 3 to go to the other side. The cubic root of 3x minus 1 equals, and this becomes 2. And what I'm going to do is I am going to get rid of a to get rid of a cubic root, I have to cube it, right? And that makes that go away. So 3x minus 1 equals, and 2 to the 3rd power is 8. Okay, then I'm going to add the 1 over. So I've got 3x equals 9, and then divide by 3. And x is 3. And there we go. Okay, all right, a couple left. Number 11, use the equation. They will give you the equation. I won't expect you to have any equations memorized, so I will always give you those equations. But the only difference is, like here, they say plus minus. Well, I'm not going to do both of them. I have to decide whether I'm going to be a plus or a minus, so we've got to decide. use the equation to solve the following. A car that is $20,000 depreciates. That's going to tell me, okay? If it's depreciating, that means it's going down in value. So instead of using the plus here, I'm going to use the minus, okay? All right, so $20,000 car. That is going to go in for my principal. Usually in this spot, we have capital P instead of a lowercase a. Whatever, it doesn't matter, okay? So I'm going to say my after amount equals, I'm going to put 20,000 here in this first spot. And then I have 1 minus my rate. And the rate is 15%, which as a decimal is 0.15. Make sure you put it in as 0.15, okay? Per year, find the value of the car after 5 years. So I'm just going to plug that in for T. And if you want to make life a little bit easier, 1 minus 0.15 is 0.85. It's just less to have to type into your calculator, okay? So you should just be able to type that in all at one shot. I am using my phone as a calculator, which is not the best option. And I'm going to do 0.85 to the 5th power first. And then I'm going to take that times 20,000. And I get that after 5 years, oof, that car's only worth $8,874 and 11 cents. Let's say we'll give it some change. Okay, that's how much that car is worth after 5 years. Yikes! 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 Okay, all right. Number 12. We're gonna list out some transformations over here. So if you want to write this down, I'm gonna take up a lot of room over here in this corner. Okay, these are gonna be some of the same transformations that we listed here, like over x and right for and up to and all that good stuff, okay? But this is specific to exponential functions. So if my parent function is 2 to the x power, like y equals 2 to the x power, let's write down what some things will do. So let's say instead I have 2 to the x power and then plus 3. Let's say I have 2 to the x power minus 4. Let's say I have 2 to the x plus 5, and the 5 is up in the exponent. Let's say I have 2 to the x minus 6. Let's say I have 7 times 2 to the x power. Let's say I have 1 over 8 times 2 to the x power. Let's say I have 2 to the 9x power. Let's say I have 2 to the 1 over 10x power. I'm running out of room. Let's go over here. I'm going to shift this all over. Sorry. I know that you can't do that. I just have 2 left. I have negative 2 to the x power, and I have 2 to the negative x power. Okay, so we're going to write down what each one of those things mean. Okay. All right, if you need to pause to write that down, go for it. We're going to write off to the side what each one of those things does. Okay. So kind of in a similar way that these guys, this meant down 1 and this meant to the left 3. It's kind of similar to an exponential function. Okay, so what is that plus 3 going to do? He's going to move him up 3. Okay, minus 4 means down 4. Down 4. The 5 is going to move him 5 units to the left because plus actually means left and minus means right. So this is the opposite. Okay, so left 5. Okay, minus 6 means to the right 6. All right, and now we've got stretches and compressions. So these numbers right here, the 7 in front, think of it as 7 multiplied by that. What's it going to do when you multiply something by 7? Well, I'm making it really super taller, right? So that's going to be a vertical stretch by 7. Okay, and the 1/8 is going to be a vertical compression by 1/8. So just the same as what it is now. Okay, then we get to these guys where it's 9 times x, but it's up in the exponent, all the way up top there, and the 1/10 is up top there. It's not pulled out in front like these guys were. Okay, so this is going to be a horizontal compression by 1/9. This is where we have to use the reciprocal. Okay, so the reciprocal of 9 is 1/9, and that means it's a compression. Okay, now let's see if we can figure out this one. This one is going to be a horizontal something by, we have to flip it, so 1/10 becomes 10. Well, if 10 is my factor, then it's going to be a horizontal stretch in that case. Okay, so a horizontal stretch by 10. Okay, this one is taking this and this one is flipping it over. Okay, so it's doing all those little things. Each one of those pieces is doing all those little things. Okay, now that's a lot of stuff to memorize, and I get it, but that's still a lot better of a process to graph things, to like have shortcuts to graph things rather than having to plot points every time. Like, who wants to make a little table of values and go X, Y, and plot points every time? Nobody wants to do that. So if I know the shortcuts of getting a function like transferred over, like the same thing up here. Like, if I didn't know what all those shortcuts did, and I had to just graph that thing, I would have to plot points. Like, that sounds terrible. Okay, I don't want to do that. Okay, I know all the shortcuts, so I can just graph him and be done. Okay, all right, so number 12, let's list the transformations, blah, blah, blah. Okay, we're starting with 2 to the x power. I know we have a lot of things happening, okay? So 2 to the x power is this guy right here. So I actually have 1, 2, 3 things that are happening to this function, okay? Now, if you don't necessarily list them in order, I probably won't count it wrong. My trig class that are doing these kind of same things right now, I do expect them to put them in the correct order, but you guys, if you accidentally get them out of order, you know, that's fine. I won't count it against you. But here is how you put them in the right order every time, okay? Imagine that I was plugging a number in for x. Would I apply the negative? Would I add the 4 to it? Or would I add the 5 to it? Okay, if I'm plugging a number in for x, I'm going to add this 4. So that's going to be the thing that's going to come first. Okay, and that 4 is going to move him to the left 4. Okay, so if I move him to the left 4, that's going to alter that. Okay, then does the negative come next or does the 5 come next? Well, obviously I would take him to the 2 to that power first, but that's a part of the parent function, right? Like the 2 is already counted in there. But the minus is going to move him over the x-axis, okay, over the x-axis. And then the 5 will move him up 5, okay? So the plus 5 moves him up 5. So these 3 things are what I'm looking for transformations as far as that goes, okay? Kind of like what we listed out up here, right? Like all of these things, that's what that means, all right? But make sure you write these guys down so you have a list of those transformations, okay? Unless you have them all memorized. That would be fabulous. Okay, we'll stop there, and we will start up with number 13 tomorrow. I know that's not quite a third of the way. Oh, by the way, why are we starting on Monday? Because Wednesday, kids are gone for track. So I am not planning a review day on Wednesday. So we have Monday, Tuesday, Thursday, and then you have your semester test on Friday. And I think they're doing evens on Friday. So you guys will test on Friday, 8th period. Okay, that is all.